Okay, sorry about that, y'all. I realized my mistake and I stopped, and then apparently I can't just keep recording on the same clip. So this will be a second clip. And so this is 9 times 4. And so if I choose to reduce it, the 9's will cancel. So this 9 will cancel with this. And what will be left inside of the radical is just the 5 and the 4. Okay? And then when you take the square root of a fraction, or when you raise a fraction to any power, you simply do it to both parts of the fraction. So what that means is I've got my I. I'm going to take the square root of the top, which is the square root of 5. It doesn't simplify or anything. And I'm going to take the square root of the 4. And it just becomes a 2. And it's not under a radical anymore, which is good because you don't want it there. And that's it. That's your simplified fraction. Now the other direction I could have gone is I could have simplified each radical and then reduced. So I still would have taken this negative and pulled it out. And so I'm just going to jump over here to the side. So it still would become an I. And then when I split this up as the 9 and the 5, I could have taken that 9 and pulled its square root out. So it would have become a 3. And I'm going to put it right here in front of the I. And it would have left the square root of 5. And then when I did this, I wouldn't have even broken that up as 9 times 4. I would have just taken the square root of the 36, which would have been a 6. But you see what's happened is because I didn't reduce the number in the radical first, now I've got numbers outside the radical that will reduce. So this would still cancel with this and leave me with the same answer. So any way you cut it, you're left with an I times the square root of 5 over 2. Okay? But this time around, when we simplify this, we'll pull the negative out and it'll become an I. And then the square root of 49 works out perfectly. The square root of 75 doesn't. Okay, and 49 of course is just 7 times 7, and this is 25 times 3, so they don't even have any common factors. I can't reduce inside the radical. So what I have to do is I have to simplify each part of the fraction first, and then there's something else I'm going to have to deal with. Okay, so I'm going to simplify first. I'm going to take that square root of 49 and I'm going to pull it out, and it just becomes a 7. Okay, and then I'm going to do the same thing here. I'm going to split this up as 25 times 3, because then I can take that 25 and I can pull it out of the square root. I can take its square root and it just becomes a 5, and then the 3 is still stuck inside the square root. And now the new thing that we're going to have to deal with, I think it was on the warm-up for class for tomorrow. You guys are going to try it for practice. It's called rationalizing. You can't leave square roots in denominators. So in order to get rid of that square root of 3, I have to multiply by the square root of 3 over the square root of 3. Now there's two reasons I can do this. The first is the square root of 3 over the square root of 3 is just 1. Okay, so I'm not changing the size of the fraction. The second reason is because these two down here, now when they multiply together, the radical will go away. So up here on top, it's going to get messier. I'm going to have a 7, an I, and a square root of 3. But down here on bottom, these two radicals multiply together and just become a 3. And then times the 5 that was already there gives me a 15. So this problem encompassed a lot more than just simplifying radicals. It also required that you remember how to rationalize from your earlier math classes. So that's why we're going to take a whole day in class and just practice this stuff. Because for some of you it may have been 1 year, and for some it may have been multiple years since you've done this. Okay. Now, complex numbers, remember, they just consist of two parts. They consist, this is the real number part, A right there, and there's an imaginary part. And you just simplify them each separately, and you simply just write it in this format. So it's not any harder, it's just going to have two parts to the numbers. Okay, so it says it gives you all the same steps. It does say here that if your entire expression is a fraction, rewrite it as two fractions with the same denominator. So that way you're breaking it up into the real part and the imaginary part up there. But I will show you what we're talking about. Now you may not have actually remembered simplifying complex numbers, but this right here is actually the quadratic formula. It just happens to already have numbers plugged into it. So let's say you're solving a quadratic and you get this kind of answer. Then what you would do, what that step was saying, is if you want it to be a real part and an imaginary part, what you're going to do is you're going to take this fraction, this huge fraction, and split it up. You're going to put the 4 over the denominator, and then you're going to put the plus, and then you're going to take that whole second part of that numerator, so 3 square root of negative 20, and put it over the denominator. And then you're going to simplify each separately. So the real part of this particular complex number is very pretty. It's just 4 over 2, which is 2. And of course this one isn't going to be as pretty. So I'm going to split this up. So I'm going to take that negative and I'm going to make it an I, of course. And then 20 is the same thing as 4 times 5. And I split it up that way because 4 has a perfect square root. So I pull it out and it becomes a 2. And so remember, we're getting kind of cluttered around here, so I've already had a 3 out there and I'd already pulled the I out, and now I have a 2 that I just pulled out of that radical, and I still have a 5 that was left inside that radical. And don't forget, that whole thing is still over the common denominator of 2. And so what's going to happen is these 2's will cancel. And so my complex number had my nice pretty real part, which was 2. And now it's got this complex part, which is a 3, an I, and a square root of 5. And that's my complex number. And so what that means is my real number, the A part, is equal to 2. And B, which is the coefficient for the I, is 3 square root of 5. Now, if it confuses you where I'm putting the I here, you don't have to write it there. There's a reason that I do. I could have written this as 2 plus 3 square root of 5I. The reason that I do that is because you've got to be really careful when you put your I back behind here that you don't accidentally make it look like this. That I has to be out behind the radical. It doesn't become an I until you've taken its square root. So you've just got to be really careful about where you write it when you do that. Okay, so let's try one more. So I'm going to take, I've got 2 parts up here in my numerator, and I'm going to split them up over the same denominator. So 6 over 4. And then I've got my minus sign from up here. And then I take this part, the square root of negative 72, and put it over 4. And now I can treat each part separately. So this over here, 6 over 4, I could reduce it down to 3 over 2, or I could write it as a decimal. I could write it as 1.5. And then I have my minus sign. And then I'm going to split this radical up. So first of all, I'm going to take care of this negative right here. I'm going to go ahead and pull it out and make it an I. And then 72 is the same thing as 36 times 2. And so I split it up like that so that I could take that 36 and take its square root, which gives me a 6. And then that 2, there's nothing I can do with it. It stays inside the square root. And it's over 4. And now I can reduce it, and then my complex number will be done. So I have my 3 over 2. And then this will also reduce to a 3 and a 2. And so I have a couple of different ways I could write this. I can leave the I up here in the numerator, so I'm going to write that way once. So I, and then I'm going to put my 3 in front of it and my square root of 2 behind it, and then over 2. So I could write it that way. Or if it looks too cluttered for you, if there's too much up on top, I can write it as 3 over 2 minus, and then I can take this I and just move it back to the back. 3 square root of 2 over 2 I. And that means that this is my A, and then this is my B. There's my real coefficient and my complex coefficient. Okay? So what I'm going to do is I'm going to post the completed notes. These are just additional practice problems for you guys to try. Technically we've covered all of these already. They're just writing them in their complex form. So I'm going to let you guys give these a shot, and then I'll have Mr. Wilson show you the answers or something in class. Thanks, and I'll see you guys on Tuesday. And once again, I'm sorry for the video format. I'll remember my iPad next time.